This is rubbish. I seem to have lost the eraser. Last time we talked about electricity and Ohm's law, and this time we are going to be talking about electromagnets, solenoids, and motors. Electricity running through a wire creates an electromagnetic field. A French physicist and mathematician named André Ampere used this when he invented the solenoid, a device that coils wire around an object, magnet, or empty space to create a very powerful electromagnet. So this is what it would look like from the side. And this is what it would look like facing on. Just have one coil of wire. The way it would work would be using the right hand rule. If you put your thumb running along the way that the current is going, for our example it's going this way, then the direction that your fingers go are the way that the current is going. So it would come out of the board here, and in here, out here, in here, out here, in here, etc., etc. Now this wouldn't really create a strong magnet, but what he did was he took this and then added a whole bunch of other coils all around the same. All of them creating an electric current, which would go around here and through the center, creating a very strong, no wait, it's this way, very strong magnetic force down this direction. We are going to be building different solenoids and testing to see how they work, and we are going to be using Ampere's law to figure out why they did or didn't work. The magnetic force of the solenoid, represented by the letter B, equals the electromagnetic permeability. Magnetic permeability, a measure of the ability of a substance to sustain a magnetic field, equal to the ratio between the magnetic flux density and the magnetic field strength. For a vacuum, its value is 1.257 times 10 to the negative 6 henries per meter. Henries are a measure of inductance. Highly magnetizable materials, such as ferromagnetic materials, have a higher magnetic permeability. Of the material that the coils surround, whether that be steel or air. This is represented by the Greek letter mu. It's spelled M-U, and not like the Pokemon. So, mu. We are using iron carriage bolts. So, for our experiments, we will be dealing with a permeability of 6.3 times 10 to the negative third power. Then, we multiply this number by the number of turns that the coil makes, which is represented by the letter N, times the amount of current in amps that is going through the coil, divided by the length of the coil. And we're not talking about how long the piece of coil that is being used is. We're saying, so if this is our nail, and we have this one coil that is a certain length. Actually, we don't have one, we have two nails. And we coil this one around about half its length. And we coil this one at its full length. This one is going to be much more bunched up, and the coils are going to be able to strengthen each other more than if they were spread out. The nail is the same length, and the coil is the same length. It's the way it's set up that's different. And this one, for this one, the answer of B would be higher. That is Ampere's law. And now we are going to show you the solenoids that we built and the motors that we built. If you click below in the description, you will be able to find the work cited and see all of the work that we used to create the introduction. If you click here, then you will see the previous video I did for this physics class, and if you click here, you will see my previous video from my channel.